what's going on? Welcome back. In today's video, we're going over ZTH Obscure Web Vulnerabilities, which is a room that combines multiple tasks about the most common application vulnerabilities. So we start with SSTI, server-side template injection, and we will go over CSRF, and lastly we'll go GWT, and of course XSE, and we finish it with some challenges. So this room, to inform you, it is a part of the web fundamentals pathway that I have been doing recently. In today's video, we're going to go over, of course, for the sake of learning, I will divide the video into, or split the learning process into multiple tasks or multiple videos. So basically, in the first video, we're gonna go over SSTI. Next video, we will cover CSRF, and so on and so forth. So before diving into SSTI, let's first understand what it is. So as per the room, SSTI is server-side template injection. I found a page on the internet that details the inner workings of this vulnerability. So you can find the page in Portswigger. The paper here talks about server-side template injection, and you can read through the page. So basically, it is just like any other vulnerability. The user or the application takes the user input and then parses the input without any sanitization. So as you can see here, template injection can arise both through developer error and through the internal exposure of templates in and templates, an attempt to offer rich functionality, as commonly done by wikis, blogs, marketing applications, and content management system. So an example of that is this one. So basically here I have a simple code that takes in the input from the user, and the input parameter is first name here. So do your first name, and then you input your first name here. Now how the vulnerability arises when we try to use the input from the user in a GET request. So here we ask the user to provide their email using a GET request. Now to test for server-side template injection, we use double braces, okay? And inside the double braces, we use an expression. In this case, the expression is arithmetic expression. If the arithmetic expression evaluates to a value, okay, then the code is vulnerable. And then we can execute multiple kinds of operations. For example, we can put self here to take an idea or get familiar with the type of environments in there. For example, the type of environment here or the type of template being used is twig template. You can continue reading if you want more information, if you want more details, if you want to get yourself more familiar with that vulnerability. So basically, I recommend you guys to go over this page before starting the challenge. It's not required to read all the paper in order to do the challenge, but if this vulnerability, or if you are new to this vulnerability, I recommend you to read all the paper and get yourself familiar with it. Okay, back to the room. So basically, let's go over now the testing methods of SSTI and then do the challenge. So as you can see in task 4, it talks about manual exploitation, and task 5 talks about automatic exploitation. I'm not going to burden you with reading through the lines. I'm going to go directly to the web application and demonstrate the practicalities of it. So basically, let me switch now here. So this is it. Here we have, let me reload. Back again. Okay. So as you can see, we have a web page that displays an input box. The input box asks a question: what is 2 plus 2? So as a user interacting with the web page, you would type 4, submit. And yeah, the connection has timed out. Yeah, actually it times out whenever I try to make the video. So let me try again. Okay, just disconnect. Okay. Oh, the IP changed. All right. So, as a user interacting with the web page, you would type 4 and you will see 4. If you click on the pre-page source, so examining the page source, we see an HTML code, and inside the HTML code, we see form or JavaScript form. The JavaScript form takes the input and stores the input in the parameter name. So the parameter here, or the variable parameter, assumingly is name, and then it submits and displays the user input back to the page using p-body or p-tag. So where is SSTI here? You may ask me, how do I know that I am testing for SSTI, right? You're right, completely right. Sometimes you can't determine the nature of the vulnerability you should be testing for just from the input. Okay, you have to try different things. So if you go back now to the room, so this is the base vulnerable code. But again, you will not be able to see the base code if you are doing black box testing. Most of the time, you will be doing a black box testing or black box penetration testing. So don't look at the code, try to determine yourself what you need to do. So this phone could be subject to many kind of testing. It could be subject to SQL injection, could be subject to cross-site scripting, could be subject to any web application vulnerability that could be among the OWASP top 10 or could be outside the OWASP top 10. So how do we know that you need to test for SSTI? Well, that's an example. That's a question that doesn't have a direct answer. You should try yourself. And as a pen tester, you don't have the time to try different kind of, you know, vulnerabilities to find out. So basically, that's why let's go over the automatic method. So there is a tool called TPL map. You can find the tool here. This tool has been created and made to facilitate the testing for server-side template injection. So server-side template injection and code injection detection and exploitation tool. And here is the explanation. As you can see, here's an example of the vulnerable code. And here you see examples of running this tool. So let's go now to the application and try to use that tool. So we have a web page, we have a form, we don't know yet if it is vulnerable to SSTI. It comes to our mind, let's test for SSTI. And here okay, so as you can see, use Python 2 to run this tool. Make sure to use Python 2 or you will encounter or run into errors. TPL map.py -u, we provide the URL, and -d, you provide the parameter name that we suspect it is vulnerable to SSTI. So based on our enumeration, if you use the page source one more time, and you see here the variable or the parameter that the user passes to the application is name. So we use -d name and we hit enter to see if it is vulnerable. The tool is running now. So as you can see, the post parameter is name, and the engine running the template is Jinja 2, and as you can see, we have multiple stuff we can do. So it's vulnerable. Shell command execution is okay. Bind and reverse shell is also okay. File write okay. File read okay. Code evaluation okay. Python code. So from these lines, we can conclude and infer that the application is vulnerable to server-side template injection. Here are the command line switches that we can use to take things further. For example, we can take type -os shell or cmd id execute command on the web application. Enter. So as you can see, we have executed the ID command and the output has been returned. The user ID has been returned to us. Now what we can do, we can take things further and establish a reverse shell. So let's split the window to right and left. Yep. NC-LVP 4545. And here we type NC up. Actually, I need my IP address. I'm gonna interrupt the connection if config. So this is me. Clear. So, and the port is 4545. If there is netcut installed on the target, it's gonna work. If there is not, it's not gonna work. Let's see. Oh, it worked. So I received now connection back to my machine. If I type ID, now we have to wait. Let's wait. Okay, let's interrupt and modify on the command so that we receive bash -e bin bash no 4545. So the code didn't execute. Okay, just like that. All right, we received the connection, as you can see, but that's not the purpose of the scenario. But this is just you know, a demonstration how you can demonstrate or how you can again reverse shell or RCE into an application vulnerable to SSTI using an automatic method if you don't have time. Now let's go back to the application and see how we can do that manually. So suppose that you are a pen tester, you have been tasked to detect if there is SSTI in your client's webpage. So you would go ahead and type double braces 2 + 2 as we demonstrated in this page. So the method here is we try to type an arithmetic operation in between double braces. If it evaluates, then the application most probably it is vulnerable. Submit. So as you can see, it evaluates to true, to 4. If we type again here self to see what kind of environment, it also evaluates. Although we are not able to see the type of template back here in the output, but we saw that there is code has been executed, template reference none. So this is this code is vulnerable. Now we can insert manual payloads. So here we go to payload all the things. From here you can find payloads for SSTI. Execute code using SSTI for Ruby. Nope. Execute SSTI by calling the subprocess open. So here's an example you can use. This one is first one, the second one. So here the first one, we try to cat files or read files, execute commands. In the next one, the same thing. We try also to list the files in the current working directory. And here also we use for if you want to iterate through the same command. All right. Now, what are the questions you need to answer? So in tasks, in task 4, you have 2 questions. The questions are about submitting the right command or the right payload to exploit SSTI. So as you can see, the first one, how would a hacker cat out etc password on the server using cat with the RCE payload. So we have two payloads we can use here. The RCE one, which is this one, it uses the method pop open or popen, sorry, and inside popen you would type your own command. So take this one payload, paste it here, but modify the command inside the popen, make it cat etc password. Let's demonstrate this here. So enter. As you can see, we are able to see the content of the password file. Next one, how about reading in the contents of the user test private key, private SSH key. So here we are trying to read files, okay? We are not trying to execute commands. So we would use the payload for reading the files. This one. Let's copy it from here. Internal server error, why? Let's see why. Let's check this out. So we may need to type cat here. Cat. We got internal server error. Let's take this one. And we modify the file that we would like to read, which is under home, all the way till IDRSA. So it's not working, this one. No idea. Clearly there is something wrong with our command. The read file one is this one. Let's try this one. So here we put the file name home test SSH ID RSA. It's not working. Okay, let's put single quote here and one single quote. Not working. Even this one is not working. Anyway, but the correct answer for this question is this one. Now, the automatic exploitation here, we have already demonstrated that, and the question is, how would I cat etc password using TPL map on the IP port? So you'd go through the same process. You would first define the URL. In your case, or in the question's case, it is lens 5000. Define the vulnerable parameter, newt-d newt, and then cat out the password file, defining --os-cmd, cat etc password. Let's go to the challenge now. I have created a vulnerable machine for you to test your SSTI skills on. I have placed a flag in /flag as well. Good luck and have fun. So you have to find out what is the value contained, what is the value in the flag file. Easy. So what we do here, you would either do it automatically, for example, clear, no need for that. So in the OSCMD, you would type cat /flag and see if this works. Let's see. So the output has been returned. It is Coctus. Now, if you want to do that manually, you would grab one of the payloads. So I would grab the RCE1, since it is the one that's working, and go to the page, try to cat out the file. So here, cat flag. So it is Coctus. Let's take the answer. So it is correct. So that is all about SSTI. Make sure to get back to this page and read through the paper to get more details about this. So that is for today. See you in the next video.